Okay, we're in passage 5. This is an experiment or research passage, so you're going to treat it again like just looking around a playground. If you're babysitting, quickly look for the variables. So in this one, it has a diagram with block X, block Y, a description of the study, maybe skim it quickly, 10 trials, string passed over 2 pulleys, block X has a mass mx, block Y has a mass my, block X is pulled down and held in place, and then looks like it's let go, and they're calculating the weight of each one, the force, the time, and then the acceleration. So not a deep understanding of what's going on, just a basic understanding is all you need. So 27, the speed in meters per second of block Y can be obtained using the equation, speed equals acceleration times time. The speed of block Y at the time it struck the platform in trial 2. Okay, so we're looking at trial 2 is correctly represented by which of the following. So we have acceleration, which is here in study 2, trial 2, study 2 is 3.27. And then we want to find time, which we get in study 1 in trial 2 is 0.96. So 3.27 times 0.96, and our answer is B. Which of the following statements is consistent with the available information about the design procedures of the studies? So let's look at choice F to start with. More trials were performed in study 2 than were performed in study 1. Okay, so let's look at study 1. They have 10 trials, and in study 2 they also have 10 trials, so that is not true. So they performed the same amount, so that one's out. Let's look at choice G. In each trial, the mass of block X was less than or equal to the mass of block Y. So block X and Y, so is it less than or equal to in every single one? And it does appear that it is, so the answer would be G. Suppose, so this is a suppose if Y question. So when you get these questions, those are ones you're going to have to think about. In study 1, so we're going to find study 1, a trial had been performed in which block Y was pulled down and then released when block X was 1.5 meters above the platform. So it's just saying that these two were switched, right? MX and MY were switched. Further, suppose that MX is 0.8 and MY was 0.6. But remember, they're switched in how we're thinking about them. The force on this string and the string of this trial would most likely have been. So we look over at our table. So once we switch them around, Y is going to be where X was, right? So Y is going to be the one pulling, and X would be over here. So 6 and 8. So the force is 6.72, right? 6, 8, 6.72. So your answer would be C, 7. Another suppose question, you have to think about it. In step 3, okay, block X had been pulled down and held in place so that block Y was 100 centimeters, not meters above the platform. So 100 centimeters, knowledge, you need to know that's 100 centimeters in a meter. So now that one's going to be lower than block Y is currently, because 1.5 meters is more than 100 centimeters. Would the values of T recorded in study 1 more likely have been greater than or less than those shown in table 1? Okay, so we're saying, is T going to be less than or greater? And so if it's lower, the time it takes to hit the platform is going to be less. And so the answer has to be J, because block Y would have fallen a shorter distance. Based on the results of the studies for a given value of x, so any given value of x, okay, as my was increased, so we can use trials 2, 3, and 4 because the given value of x is 0.2 and they increase. Which of the variables f, t, and a also increase? So let's look at them one at a time. So if we look at f, f does increase as the values go up. So it goes from 2.6 to 2.9 to 3.1. Now let's look at t. All right, so t goes 0.96, 0.78. So t does not increase, it decreases. So now if we look at our answer choices, we have the answers because it can't have t in it. And then we know it does have f. If we want to double check a, yes, it increases as well. So your answer has to be A. So force increases, time decreases, acceleration increases. Based on the description of study 1, was y a dependent or independent variable? So this is a little bit of knowledge. You have to know dependent means value depends on something else. So in this one, for example, time would be a dependent variable. But independent is when the value doesn't depend on something else. So y is just the weight of block y, the mass of block y. So that makes it an independent variable. Its value was intentionally set. It's not obtained by the value of something else. So a bit of a knowledge question, H. 33, we also have a little bit of a knowledge question. Consider any trial in which the block masses were not equal. So it doesn't matter which trials, but the block masses were not equal. In this trial, once block X has been released, so once block X is let go, the gravitational and potential energy of block Y immediately begins too. So it decreases, right, because it's losing height. Potential energy is the potential it has for energy. So the higher you raise this, the more potential energy it has, and as it falls, it has less potential energy because it's eventually going to stop. So your answer has to be D. Its value decreases because it begins to lose height. And that's a bit of a knowledge question as well.